everyone. Today I'm giving a tutorial about entity relationship diagram. So before we start, let me introduce myself. I'm Angeline Cabezas. So no more introducing, let's start our tutorial. Entity relationship diagram or ERD. ERD is a visual representation used in database designed to illustrate the relationships between entities, which can be objects, people, concepts, or events within a system. ERD involves recognizing its fundamental role in conceptualizing and designing complex data systems. At its core, an ERD is not just a technical tool, but a visual language that bridges the gap between abstract data concepts and their implementation. What you learn. What entity relationship diagram is. Entity relationship diagram notations. Main component of an entity relationship diagram. Creating an ERD and what tools should be used. Turning the entity relationship diagram into SQL. What is an entity relationship diagram? ERD stands for Entity Relationship Diagram. It is a type of diagram used in database modeling to visually represent the structure of a database. An ERD illustrates the entities in the database, the relationship between these entities, and the attributes associated with each entity. Entity relationship diagrams are used to establish and communicate a consistent vocabulary, illustrate business rules related to a domain, plan and set up databases that store relational data. The key components of an ERD is entities, objects or concepts that can have data stored about them, attributes, characteristics or properties of an entity, relationship, how entities are related to one another. The chain notations in ERD. Entity. In an ERD, entities are usually represented by rectangles. The weak entity, the associative entity, the relationship. The relationship represented by diamonds that connect entities. The identifying relationship, the attribute. The attributes are usually represented as bi-ovals connected to their respective entity. The key entity or the so-called the primary key. Attribute, multi-valued attribute, derived attribute. The crow's-foot notations in ERD. Crow's-foot notation is another popular method for representing entity relationship diagrams. It is particularly favored for its clarity and simplicity, especially in large and complex databases. Unlike the chain notations, which uses shapes like diamonds and ovals, crow's-foot notation uses specific symbols to represent relationship between entities, making it more compact and easier to read. The main components of ERD: the entities, the attributes, relationship, and the cardinality. This is the entity. For example, uh, instructor, student, employee. Next, attributes. This is the attributes. For example, employee ID, student ID, instructor ID, or the address, the date. Next is the relationship, the connectors. It can read like can borrow, can purchase. The cardinality. Entities. An entity represents a real-world object or concept that has a distinct existence and is relevant to the system being modeled. The attributes describe the properties or characteristics of an entity. Each attribute represents a specific piece of information that is relevant to the entity it belongs to. Attributes help to define what data will be stored for each entity in the database, making them crucial for database design. The relationship represents how two or more entities are associated with each other. The last one is the cardinality. Refers to the numerical relationship between entities. It specifies the number of instances of one entity that can or must be associated with instances of another entity. The mapping cardinality expresses the number of entities to which another entity can be associated via a relationship set. The number of participating entities in a relationship is 0 to many, 1 to many, 1 to 1, 0 to 1, many to many, 1 optional to many optional, 1 mandatory or 2 1 optional, 1 mandatory to many mandatory, many optional to many mandatory, and the last is many optional to many optional. Those are the mapping cardinality that we discuss later in drawing on ERD later for that tutorial. Next is the normalization basics. Normalization in the context of entity relationship diagrams or ERD refers to the process of organizing the attributes and the relationships in a database schema to reduce redundancy and dependency. This is achieved by decomposing larger tables into smaller, related tables while maintaining data integrity and eliminating anomalies during data operations like insertion, deletion, and updating. One normal form. Ensure that each table column contains atomic values of a single type. No repeating groups or arrays. it is usually called 1NF, the normal form, for short for one normal form, the 1NF. The impact of one normal form in ERD is to ensures that each entity is well structured with atomic values, eliminating any repeating groups. This leads to a clearer, more organized ERD where relationships between entities are more explicitly defined, helping to prevent data anomalies and redundancy. The ERD after applying 1NF will typically show a more granular and organized data structure compared to an unnormalized diagram. Next, um, second normal form or 2NF. The table should be in 1NF and non-key attributes should be fully functionally dependent on the primary key. The impact of second NF in ERD is to applying 2NF to your ERD helps create a more efficient, consistent, and reliable database design by removing partial dependencies and reducing redundancy. The last one is the third normal form. The table should be in 2NF, and all attributes should be directly dependent on the primary key, not on other non-key attributes. For example, no transitive dependency. The impact is 3NF takes normalization a step further by eliminating transitive dependencies, which improves data integrity, reduces redundancy, and ensures a more efficient and logical database design. So we're going to create a simple school database system. First, click this create new diagram. Then rename this whatever we want. So for me, I'm gonna rename it as example ERD. Then click this create button. Then scroll it down. Then click this entity relation. So first, we have 5 entities: the student, course, instructor, enrollment, yeah, only 4. Then click this entity. Entity represent as rectangles. Then rename it, rename this student. So the entity student, it has 4 attribute. So click this attribute. It represents as O1. And for the primary key, Click this. It has a underline. For the primary key, you type this as student ID and attribute first name, next last name, date of birth or DOB, and the email. Then you should add a line to connect the attribute and student and the student entity. Drag this Then, for the next entity, drag again this rectangle and we rename this entity as course. Then, for the course attribute, it has 3 attribute and 1 primary key. Drag this oval. Then 1 primary key. Then the line to connect. Then add another entity for the instructor. Drag again this rectangle and rename this as instructor. And the instructor, it has 4 attributes and 1 primary key. Then 1 primary key. For the primary key, we have instructor ID. Then first name. Next is last name. Then the email. Yes. For the office. Drag again another line to connect. The next entity is for the enrollment. Drag again another rectangle and it has 1 attribute. The rest is for the foreign key and the primary key. rename this entity as enrollment ID. I know, for the enrollment. In this attribute, we will rename this as grade. For the primary key, it has enrollment ID. For the foreign key, student ID. And course ID. Primary keys, a unique identifier for each entity. For example, this is the student ID foreign key. Enrollment ID. It is the enrollment primary key, the enrollment ID. And for the foreign key, attributes in one entity then that link to the primary key of another entity, establishing a relationship between the two. And for the relationship represent as diamonds. We use one-to-many mapping cardinality. And another relationship is for course and enrollment. So add another diamond, place it here, and then here. Again, we use the one-to-many. Just drag it here. Next is the course and the instructor. Drag again another relationship, which is the diamond. Then one to many in cardinality. So in this, student enrollment can enroll can enroll. So read that as student can enroll multiple courses. One student can enroll many oh, multiple courses. Okay. In the course and enrollment, write this. We can type this as can have many students to enroll in. Then next is the course and the course and instructor. An instructor, a course is taught by one instructor. Is taught by one instructor. Page 7. The student table is this is the student table. This is the student ID. It is the primary key, uniquely identifying each student. The first name, last name, date of birth, email are the attributes of the student. Next is the course table. The course ID, oh, wala. Course name, description, next, credits, and the last one is the primary key, which is the course ID. Course ID. Then next is the instructor table. Instructor ID is the primary key, and the first name, last name, email, office are the attributes of the instructor. And the last one is the enrollment table. Enrollment ID is the primary key. Student ID and the course ID are the foreign keys, linking each enrollment to a specific student and course. And the grade is the attribute. It represents the student's grade for the course. So we can read this as student can enroll multiple courses, which is enrollment and the courses. And a course can mainly students to enroll if so connected in this. The course and instructor is taught by one instructor an instructor can teach multiple courses. So this is for the ERD diagram on how to create. First is open the sum control panel. First, click this admin for the Apache. And next is for the MySQL admin. First, we create a database. Then, rename it. Database school. Then, create. Next is click this SQL tab and start the code. Create table student and open parentheses and enter student ID for the primary key, then int for integer and the primary key, then comma. Next is enter, then the attributes, first name, varchar, and the number it contains. Next is last name, varchar, and the number it contains. Next, the date of birth, short for DOB, and the date, comma, and for the last email, varchar, and the number it contains, 100. Then enter. Then for open and close parentheses, open and close parentheses, and the semicolon. Then click this go button. Yes. Next, create table again for the course table. Create table course. open parentheses, and the course ID, and int for integer, and the primary key, then comma. Next is course name for the attribute course name, varchar, and the number 100, then comma, description, x, then comma, and the last one is the credits, int. Credits with int because it's number. Then close parenthesis, then the semicolon. And click this button again, row, okay. And next is the for instructor table. Create table, and the instructor, open parenthesis, instructor ID, int for integer, and this is the primary key. Then comma, next, first name, the number it contains, then comma, next is the last name, varchar, and 50, next is the email, new varchar, and 100, the number it contains, then the last is for the office, varchar, 50. Then click this button, okay. Then next is for the enrollment. create table enrollment 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 ID int primary key and comma student ID int na comma next course ID course ID int next grade char two the number it contains then comma then the foreign key student open parenthesis student ID close parenthesis then the references student student ID comma next is foreign key again for the course ID then the references course ID then the close parenthesis and the semicolon. Please click this row. Okay. Next is the course instructor table. This is for optional only. So we create instructor.